Astronomers categorize billions of galaxies into just three major types based upon their shape: spiral, lenticular, and elliptical. Spiral galaxies are flat and organized with a pair of distinctive arms twisting away from their centers. Lenticular galaxies are also flat and rotating, but they are disorganized and chaotic. The cores of these flat galaxies are called bulges because the centers protrude above the flat plane. Finally, elliptical galaxies are not flat at all, but they are ball or egg-shaped and very disorganized with few stars outside of their central core. Now, spiral galaxies, such as our Milky Way, are the flat disks of mostly younger stars, which revolve around a dense, tidy center bulge of mostly older stars. The bulges made new stars more rapidly and exhausted their gas. That's why their stars are older or later generations. In the center of the bulge, we often find a black hole, which contains less than 5% of the galaxy's total mass and does not create enough gravity to form galaxies. Spiral galaxies have rotating pairs of arms extending from their central bulge, usually connected by a bar of stars. It is crucial to recognize that the spiral arms are only found in pairs. We never observe a spiral galaxy with an odd number of arms. This fact is a major, but usually overlooked clue to solving the mystery of galaxy formation. Now, the spiral arms range from clearly defined and very distinct to vague and fuzzy, and contain large amounts of gas and dust, which make new stars typically found in the arms. Most modern spiral galaxies have a bar of stars across the central bulge to connect the innermost ends of the two spiral arms. Now, let's look at lenticular galaxies, which are sometimes considered the medium or intermediate shape. They are named for their lens-shaped. Basically, they look like a frisbee. And they're somewhere between the chaotic elliptical and the orderly spiral. These galaxy types have mostly older stars and limited amounts of dust and gas for new stars. The central bulge of these galaxies is chaotic and disorderly, and the stars are moving in random directions. Lacking the arms and orderly structure of spiral galaxies, these lenticular galaxies rotate around a bulge which often has a central bar. Sometimes these galaxies are referred to as armless spirals. If we view this type of galaxy on edge, it looks like a flat spiral galaxy. However, when we view them from the top or perpendicular to their plane, they look like elliptical galaxies. Now, let's look at elliptical galaxies. These are spheroid or ball-shaped. Their large round centers are densely packed with stars orbiting randomly. They have very few stars outside of these central cores. These elliptical galaxies have very little dust or gas to make young new stars. So they have later generation stars and are often referred to as red and dead because they make no new stars. The most massive of these elliptical galaxies possess large amounts of matter and have the largest central black holes. They have the greatest star densities in their surrounding central regions. These huge balls are only found stuck within great walls and are never moving out in the open space. Let's now turn to our whiteboard and we shall see a picture of these three different types of galaxies or shapes. First, we'll start on the left where you have your elliptical galaxies. These are the red and dead ball-shaped galaxies. And we look at their characteristics down below. They are round, they have a dense core, it doesn't make pattern or organization, mostly older, later generation stars, without dust or gas for new stars. We then look at the number 2 variety, the lenticulars. These are also flat and spinning, and these are flat spinning unlike the ellipticals, but like the spirals. They're disorganized like the ellipticals, and they mostly have older stars, but they do have some newer stars and some dust or gas which is used to make the newer stars. Lastly, we have your spiral galaxies, and this is like your Milky Way. Now, these are flat and rotating. They are highly organized. They come with a twisting pair of arms and they have a lot of gas and dust out in those arms, which makes the new stars. The new stars are shown as blue, and that's basically what you see. They often have that bar of stars going across. Now let's look at the bottom layer of this whiteboard, and we shall see what the expected white hole looks like in each of these type of galaxies. The elliptical galaxy has a white hole which is broken. It is in 3 dimensions and it's blowing gas in all different crazy directions. That's why these stars, these central cores, are very chaotic, and it's also why, because of the inhibited gas flow, because of the chaos, is why all the stars are mostly near the center, rather than being able to blow out towards the outside. Now, let's look at a lenticular galaxy. Their white hole is cracked, but it's still flat. It's only got 1 crack. But it is a bit messy because there is some turbulence in those white hole jets, because some of the white hole jets are running into each other. But since it's still flat, the galaxy remains flat, and that's why it's disorganized. Now let's look at the spiral galaxy and the white hole there. What we find there is a white hole that is perfect and uncracked. It is perfectly flat, and therefore its hydrogen gas blows out in very flat and neat patterns, and that's what creates the arms, which later twist around the galaxy. And that flow is uninhibited, which is why this type of galaxy, the gas blows very far from the center, and why it is the least dense type of galaxy, and why they blow out further. Thank you very much. Have a nice day.